Big round of applause for Paddy.
Yay. Okay, so fixing MVP. This is something I've had a bit of a pet peeve against for a long time as MVP and how it's done really badly, in my opinion. So first of all, we actually better define a problem, because if you do it the other way around, bad things happen. So current MVP implementations tend to get really, really messy, and they get really bad really fast. And they turn into this sort of fragile and confusing nightmare, particularly around testing. I'm sure you've all come across the issue where you have a pile of Mockito methods mocking a lot of different methods, and there's no real connection as to what they do. And this is the issue I have with is this Google sample. I'm frustrated by it. So this is what we think of when we see MVP, isn't it? Something like this. Something nice, clean system. Unfortunately, on Android, due to Android, you get this. You get this activity, talking presenter, and a lot of back and forth happening that isn't really related to views. So essentially, the activity manages part of the view. This is like action bar, toolbar. Sometimes your nav drawer is up there, and then you can put the other part of your view in a fragment, and then you've got these sort of two views talking to the same presenter, and it ends up getting quite difficult. So basically, this is the issue. That bridge becomes a big mess. And we end up with this circular dependency. So I'm sure you thought of the issue where you either have to use a method injection to set the presenter on the view, or the other way around. And the view-presenter interaction just goes on and on and on. It gets more and more tangled the more time you spend on it. So what I think the actual issue is, we never separate our code. We just sort of smeared it across multiple classes. So this is what I've come up with. I slapped RxJava all over it and hope it worked. So it's our reactive model view and presenter. So the main concept is to treat the activity or fragment as a main method, nothing to do with the view at all. Have all the view logic moved out of the activity or fragment. And in fact, the whole point is to get rid of fragments because I hate them. And the way I did this was I created a completely standalone view. So who here creates composite views or compound views, where you have a view group and you inflate a layout directly into it? Yes. Think of that, but the entire activity. And this is what the actual activity or fragment will render. And then we're going to use RxJava to implement the observer pattern. This is to tidy up the circular dependency problem, and because RxJava is amazing. And one thing we actually did recently was to take the data events from the system. So coming from the activity, these are on activity for result calls, intents, broadcast receivers, and actually move them into where you put your database equivalent. So they're actually not in the view anymore or the activity. They're off in their own little area. So why did I integrate RxJava? Because it provides a really nice common abstraction for observing our data events and handling threads. It's really useful. Actually, quick question. Who uses RxJava? Who has used RxJava beyond retrofit? Okay, cool. I see that a lot. So yeah, we just wanted to fix the circular dependency between the model, the view, and the presenter. So I'll explain how that works in a second. Remove some object orientation, because I think object orientation can be peculiar in some cases. You end up with weird things happening. And we wanted to replace that with some more reactive functional stuff to pair away some of the classes we were creating. We were creating all these factories and builders and stuff that we didn't actually really need. And of course, RxJava allows you to create observables as sort of like a block of functional code that you can pass around then fairly easily. It's sort of like a pseudo-functional type thing. It's weird. And of course, RxJava has really nice ways of creating quick events, and mocking observables is super easy for testing. So this is what we ended up coming up with at MTT. So you'll notice the actual activity is up the top, and it's delegating its responsibilities to the three different components. You'll notice the presenter, all the arrows are coming out of the presenter, and there's no arrows going back into it. So the presenter is asking the view to observe an event for like a click or a tap or a scroll, and it also updates with data. And then it observes the model for data changes as well. And the model actually observes the activity for those system events or broadcast receivers and stuff like that. You have to go through the activity to connect them up. And then the activity just renders the view, and the lifecycle then comes through the presenter. So this is what the activity fragment does. It just bridges to the Android system. Its only responsibility is to actually connect your code up. Creates and manages all this, acts as a data source for the model, and provides context for view inflation. So it's just to get your theme going, to get all that ready. And it informs the presenter of lifecycle events. So I've actually got a little bit of a code sample using Dagger 2 here. This is the entire activity code. There's nothing else. The entire view is contained in here. We've got our presenter getting the lifecycle events where it sets up its RxJava chains. Dagger 2, if any of you are familiar with it, this code sets these variables. That's all you need to know. And you'll see we're passing the activity into the module for Dagger. This is what allows the view and the model to depend on it directly. So if you actually talk about the view a little bit, it's, as I said, separate into a single composite view. If that doesn't work for you, you can also just create a standard POJO or just have an object in general and have that contain your view and then just figure out a way of getting that into the activity. It's instantiated by us or dependency injection, not by view inflation. This means we have full control over constructor arguments, so you can actually pass in like Picasso instances and stuff that are only contained to the view. And then the activity displays the view using the setContentView method because it can just take a view object after our injection. We've no dependency on the presenter. We control everything through RxJava to relay the events backwards. So this is what a view looks like. So this is the interface. There's the actual thing. So we're extending the frame layout. I've actually hidden what's in the constructor. It's all just view init stuff. You can see we've got our custom constructor. Android will actually yell at you for having the wrong constructors in a view, so I had to subdue that. Then we've got the various menu clicks. I'm just using Rx binding to connect everything together. So we've got our item clicks coming through here for different list items. I built this sample app for this on the Reddit API because it's easy and free, and actually a terrible API if you actually look into it. So the model class is just a proxy. It only just connects our data sources to the presenter. What I found was when I was importing piles of the entire database class into the presenter constructor and all this other stuff, I only actually needed maybe 2 or 3 methods at the end of the day. So I found it much easier to just put all this stuff into a model and isolate it. It also made mocking the model for testing the presenter much easier. So it manages all the data from the activity. This includes save states and intent data. So your saving state in your activity is no longer controlled by the view. It's actually considered the equivalent of putting it directly into a database. Now, it is actually saving in the activity save state. I have a little library for doing that. Simple logic. We keep the odd mapper filter in here just to clean things up a little bit, and we don't put any complex data processing in here. That's all for the presenter, so we can test it. If you find your model's getting out of control, sometimes you can separate into a data. You've got your system stuff, and you've got your navigation class, so you can break it into smaller parts. So this is what the model looks like on my sample app. So we've got the home activity as a data source, as a dependency, and we've got a Reddit service that's just a retrofit service. This is getting the current save state. So this is what's coming out of the activities on create bundle. So this function here will just pull that out of an activity for you. It actually uses headless fragments under the hood to figure out how to do this because you can't, it's weird. Anyway, it's Android. We just have a retrofit call. Here's where we're updating our save state using that save state library. And then we're calling our system, our actual Android system here, to start the next activity and to move forward. So this is where you would also register a broadcast receiver as well and that kind of stuff. And it would come through the observables. Then we've got a presenter. And really, it's quite simple. Just uses Rx to glue all the stuff together and just connect it all up. It's completely stateless in that the state is contained by RxJava, so I don't have to deal with it anymore. And that's it there. So we've got a composite subscription, which is just a group of subscriptions. If anyone doesn't use Rx, subscription basically is a way of cancelling off an asynchronous operation. So in our onCreate, we load our, for the example here, we load our start. It comes through to this method, which is actually shrunken. I got those the wrong way around. Just imagine it's this one. So this here we're handling our view clicks, and then we're flat mapping that to a load Reddit items, which is just an observable here because it's reused a few times in the presenter. And then we're just subscribing and setting that back to the view when we're done. And here for list item clicks, it's going forward into our detail activity. If you're doing multi-pane, it can get quite tricky. So what you can actually do is you can take your view. A great example of this is the famous detail flow, or the master detail. So you can have your master in one half and your view in the other half, and then you can take these sort of blocks of model view and presenter and connect them and reuse them across multiple activities. So you can break your activity down into large chunks for reuse. And then we use this little wireframe here, which relays events back and forward. So we have a container view, which is composed of smaller views, and then the wireframe relays data. So if the presenter, let's say you get a click, comes through the presenter will relay that to the wireframe, and then the wireframe is being observed by another model, so it goes back around and into the other view. So this will be something similar to the idea of having an activity implement a fragment communication interface, as you might have had before. For testing, everything can be tested except the views, because Android, and I don't use Espresso because I find it just weird and hard to use, mostly because I'm too lazy to learn it. We can easily mock events with observable just and never. Our views, well, you can test the views with Espresso if you really want to. So this is what a test looks like. We just mock our view and our model. We load some resources, some mock data, and then so here's an example for when this is requested, the network data, we just return observable.just. There's your entire mocking done. For retry click, if we want to disable the click event, so we only want to test one button being clicked at a time, we would use observable.never, which means it won't send a click event ever. If you use observable.empty, it sends an on-complete event, which causes your chains to get kind of screwy sometimes if you're not careful. The schedulers, just ignore that. That's an injectable set of schedulers I use, so I can override them to force everything on the thread. And then we call our actual method we're testing, and then we verify that the various things that we expected to happen happened. And hopefully it all works. And you don't get lost in RxJava because it's confusing. So there's a app on my GitHub, the RxMVP app. All that code's in it there if you want to see the full version of it. And there's a couple of activities in it. There's a Kotlin implementation of it as well in there, if you're interested. So the libraries I had to make this actually function was the Rx state library. That's the one that you can use anywhere in an Rx chain to save state and to return your state back. So this is very useful if you want to combine data sources together. The Rx intent, that just wraps the start activity for results. So you can just start it with an observable and it just comes back for you. And then we've got the schedulers thing for optimized schedulers for Android. You can take a look at that yourself. But beware the golden hammer. Rx is not a cure for everything. Use it sparingly if you can help it. It's very easy to get into a situation where everything looks like a nail. And that's it. Questions? If you're wondering, Twitter won't allow you to have a long username. So I've got that. Any questions?
I was wondering, actually.
Yes.
So you say not to overuse it, but
The entire thing's based on it.
how do you, yeah.
A good example would be if you're, one of the examples in the app is where I have an intent coming into my activity, and I can just load the data rather than have an observable load the data and set it on the view of the chain. I can just, in the presenter call, just get the data straight and just set it directly. You don't have to use Rx for everything in this. A lot of it is based on Rx because a lot of stuff in Android has to be done asynchronously, or you're sending out something waiting for user action to come back. For example, a dialog box is a really good case for an observable from the view. Just be careful because you can end up in a situation where you're using it for everything and then it doesn't work sometimes and you have to refactor a pile of stuff and then you lose track of all your type inference through lambdas. And yes?
Do you ever find that you're fighting against the frameworks at all?
It's been mostly smooth. I actually have found if you keep the stuff isolated, so if you keep the data part of the actual communication with the framework in the model and the view part in the view, generally you're not fighting the framework anymore. Or it's very minimal anyway. Yes. Can you give me an example of one? What do you mean, like, is in like the call on destroy from the presenter, or? The presenter is created by the activity, and then the activity calls the presenter's on create and on destroy methods directly. What? Okay. Fair enough. Any more? Okay then.